So we're going to continue working on factoring, starting with the pattern that I've showed you guys all along, ax squared plus bx plus c. Today's lesson focuses on quadratics that have a being greater than 1. By the way, this plus here and this plus, actually it could be positives or negatives. It really doesn't matter. The technique that I've been showing you guys works in all those cases. So we're just going to continue practicing so you guys can really get used to what that looks like. We're only going to do examples 1 and 2 today, and those are examples where the a value is positive. So to start with, let's look at our first example. I'm going to give you 2b squared plus 13b minus 24 as our first volunteer. And the first question you're going to ask yourself is factors of whatever a times c is that have a sum of b. So a times c is 2 times negative 24, which is negative 48. Negative 48. So we want factors of this whose sum is equal to a positive 13. So we've got 1 and 48, 2 and 24, 3 and 16. 3 and 16, that looks like our winner, 3 and 16. In order, though, for 3 and 16 to work, and notice I didn't put positive, negative, and create a negative, that means one of these must be negative and one must be positive. So negative 3 times positive 16 does give me a negative 48, and negative 3 plus 16 does give me a positive 13. So both of those pieces are met by those factors. So let's go ahead and follow the steps we've known so far, which is bring down the first and the last component, 2b squared minus 24, and insert these numbers next to what they would factor, or I'm sorry, group most easily with. The 3 will only really group with the 24, whereas the 16 can group with both. So we're going to put the 3 next to the 24. Also, always attach that variable. And the 16 next to the 2. Always attach the variable to those two middle pieces. Factor by grouping. Out of 2b squared and 16b, we're going to pull out 2b, b plus 8. And out of negative 3b and negative 24, we're going to pull out a negative 3. Remember, our goal is what's left within here and here are the exact same thing, because then we can combine 2b and negative 3, because both of those pieces are being multiplied by b plus 8. And you now have your first answer. And that's example 1. Let's go ahead and look at another one. And we're going to continue to follow that same pattern. I know this is all, again, another lesson, but this technique works for all of those, whether or not A is 1, whether or not B is negative or positive, C is negative or positive, it doesn't matter. And remember, this is the little pattern using A and B to identify the different locations here and, of course, C. So example 2. This one might be easy. We'll go ahead and do it anyway. 5y squared minus 17y plus 6. We want factors of a and c. That's 5 times 6. Factors of this that have a sum of this. So 1 and 30, 2 and 15, ding ding, 2 and 15 will give us a positive 30. If both of these are negative, it'll still give us a positive 30, and it'll still give us a sum of negative 17. So those are our factors. You could keep checking if you want, but 3 and 10 doesn't work, 6 and 5 doesn't work, only those work. And that's why we've been practicing the same technique over and over. 5y squared and positive 6. Bring down your A position and your C position. Place your two factors next to what they most clearly are divisible with. The 15 I'm going to place next to the 5 with my y, and the negative 2 I'm going to place next to the 6 with my y. Factor by grouping here and here. Pull out the 5 and the y, and I'll end up with y minus 5. If I pull out a negative 2, that should be a 3, Mrs. Myers. Sheesh. If I pull out a negative 2, I have y minus 3. Since both this and this are being multiplied by y minus 3, I can group them together. And I have my factors. 5y minus 2, y minus 3. We're going to do one more real quick. Even if it's big, bad, and ugly, it can be done. Here we go. 2a squared minus 15ab minus 27b squared. Factors of, what's 27 times 2? Negative 27 times 2, negative 54, that have a sum of negative 15. So 1 and 54, obviously 2 and 27, 3, no. How about 6 and 9? 6 and 9, does that seem to work? Let's see. 6 times 9, 1 positive, 1 negative, will give me that, but that won't give me the sum in the middle. 3, 4, 5, 6, 7. Let's see, let me get my 54. 1, 2 and 27. 3, 3 and 18. 3 and 18. Notice these two, when added together, do equal a 15, but there's no way to make them multiply together and give us a negative 54 and also add together to give us a negative 15. So that one was a little bit tricky. But 3 and 18, if 3 is positive and 18 is negative, will multiply together to give us a negative 54. And when they're like this, add together to give us that negative 15. So let's bring these down. 2a squared, negative 27b squared. The 3, all right, we're going to put the negative 18ab and positive 3ab. I'm running out of time. 2a, a minus 9b, and plus 3b, a minus 9b. Look at that. Finished it in the nick of time. 2a plus 3b, a minus 9b. That's it. That's all I have time for.